All right, guys, welcome to March 15th, Computer Engineering 102, second course in computer programming, thinking and objects. It's March 15th, 2023. And speaking of that, let's get right to it. Our quote of the day. Some of you might know what this means. Beware the Ides of March, that it is refers to the 15th of March. Specifically, this quote comes from the play Julius Caesar by William Shakespeare, when the soothsayer, the fortune teller, was trying to warn Caesar of his upcoming death by being murdered on the 15th of March. Was that historical? We don't know, right? Did that really happen? Did some fortune teller really try to warn Julius Caesar? Don't know, but William Shakespeare had that as part of a foreshadowing in his play. Unfortunately, we were not able to, as a class, celebrate yesterday. We didn't meet together yesterday, so we weren't able to celebrate Pi Day, but I guess we can celebrate the Ides of March Day. No, hopefully no one dies today in the class. Hopefully none of you get together and decide to kill me. That would be really, that'd be sad for me. But anyway, so that's today. That's fun times, right? Kind of a downer, but all right. Let's finish up.
Hocam.
Yeah.
May I ask a question?
Sure.
Today I was just going over the last week's lessons. I mean, like all the previous lessons. I think the one that I was going through was like 2 weeks ago. So the recording said, and when I clicked on it, the recording said it was 50 minutes long, but I couldn't really connect the subject from the last video. And the meeting said it was 1.5 hours long. So, are there some missing recordings?
Well, okay. So one is we meet for like 50 minutes, and then I pause, and then I stop the recording, and then it makes a second recording for the other half of the class.
Also, the second recording is in another class group in Teams, or is it just gone?
No, it should still be there. There should be multi. If you expand, let me see if I can pull it up here under my view here, because I think I know what you're talking about. If you're talking about this one here, so if you do the replies, it's something with Teams. So you see, there's a second. Yeah, so there's other recordings here in the chat. So like this one here, and Teams did this weird thing last week where it would like record for 18 minutes, then it would have some type of internet hiccup where it stopped. But usually what will happen is there will be one recording somewhere in the chat that's the first half of the class, like 50 minutes. And then you see there's it's 18 minutes.
You can see the previous answers. I just saw it. All right.
Yeah. Yeah, so it's a Teams issue. By the way, I don't know if you saw or not, I tried to post it here. Let's see. Not that one. This one here. So all of the video recordings, once we do them, I'm going to download them from Teams and upload them to my YouTube channel. So there's a playlist here that you should be able to get to as well.
Thank you. Thank you.
Sure. Okay. Yeah, Teams, I don't know why Teams does it that way. So, all right. So we talked about thinking in objects. One of the objects that you've used quite frequently is the string class, right? So we've used the string class to create string objects. Because string is so often used, is very common, used a lot in Java and in programming, it gets treated slightly differently than other objects in Java. Okay, so there are some methods that are common to many different objects, such as equals and compare to, but we can also have methods like concat. One of the things that we'll talk about in just a moment is what's called interred strings, but also remember, one of the things that we talked about last time was how to construct an object, right? this was the primary way that we created an object, right? Is you create a reference variable, right? Like you create a reference variable to point to the object, then you create the object using the new keyword followed by the class name followed by any parameters that we want to pass to the constructor, right? This was the way that we said, okay, this is how objects are created, right? Created and variables that point to them are created. But you know from CSE 101 that we can also create strings like this, right? But we can't create other objects like this. So why can we create strings like this? And again, it's because strings are so commonly used that Java gives us a special way to create them that's easier than having to go through the conventional, the normal method here. Okay. How do we can create a string like this, right? Again, because strings are used frequently, there's a shorthand way to create them. One thing we talked about was that strings are, with that special word, immutable, meaning that we cannot change the values in a string. So here, string s equals Java, s equals HTML. This does not change the value in the string object. This doesn't change the individual characters in the string. This makes s point to a new string object in memory. So here, like this, right? String s equals Java means we create an object for that Java string. We point s to it. After executing s equals HTML, we create a new string object for HTML, and s points to it now instead of the old string for Java, right? Okay. Now, again, like I said, one thing that we get access to is called interned strings, which means that if some strings are frequently used, we will create one object for it instead of having to create multiple objects. So, for example, here, string S1, we create it using this welcome to Java. So we create a string object for welcome to Java. String S2, new string, welcome to Java. Notice it's the same value, but because we created it using the new keyword, because we did the new keyword, that forces, at runtime, that forces it to create this new object. Okay. But then when we come back and say, okay, string S3 equals this thing, welcome to Java, right? At runtime, it says, wait, I made that before. I made that exact thing once before. I know what that is. Well, I already created it. So I'm just going to point this to that same thing again. Okay. So now if we display S1 equals S2, that's false. Wait, why is S1 equals S2 false? They have the same value. It shouldn't be S. Have the same value. Why is it false?
Hocam, because we define S2 as a new string object, it's totally different from both of them.
Right. Yeah. So it's different from that, but yeah. Notice that it is a different object in memory, right? Just like we talked about last semester with the arrays, right? Even if they had the same values, if it was two separate arrays, that was two different things, right? What the double equals is saying is, do these pointers contain the same value, right? Does this point to the same thing? Well, S1 doesn't point to the same thing as S2. S1 does point to the same thing as S3, so therefore that would be true. Okay. So I didn't pull it up yet. Let's see. All right. Here we trace through the code. This creates a string object for welcome to Java. This creates a new string object for welcome to Java. This says point to the old thing that I created before. Okay. So let me do this. Let me pull up. Pull up my JGrasp because I want to see about some, because I have a couple of questions I want to ask now because there's some things I want to figure out. Okay. Which one is this? Is this chapter 10? I need chapter 10. Okay. All right. So let's. What I want to do is I want to see what happens when we create these strings, and let me show you that this works. So string s1 equals, well, 2. They all point to this, so they all have the same value. The reason why I want to show it this way is because I want to show you the memory values over here in the browse, right, when we do that. Okay. Are we not responding? Okay. All right. So now, if we go and we run the debug, that's weird that it's doing that. Okay. All right. So now you see object and its memory address is 176. This has a different address, and what we're going to see is this has the same address, right? So 176, 176. Okay. So now my question would be, what happens if I do this? Now what happens? Right, you're absolutely correct, Batuhan. If we change it to be dot equals, then we aren't checking, are they pointing at the same thing? We're saying, do they have the same value? It's a string method, right? Okay. So now we run through this, okay. S1 is going to have, okay, that 176. S2, 181. What about S3? Will it have will it have either of the other two? Right, different from either one, right? Different from either one before, right? Because we were saying we forced it to be new. Okay, so now they're both false. Whereas before they were I did something so wrong. Oh, I can't believe I did that. No one caught this. So question, okay. Take home, think this is so going to be a quiz or exam question coming up soon now. Don't answer in the chat. Don't answer in the chat because it'll be a quiz or exam question, I promise you. I'm thinking definitely. Why did this and this produce different results? Watch.
Is it because of parentheses?
Right. Well, clearly, what we're going to see is we're in here in a moment. If it'll hurry up and run for me here. Okay. Clearly, okay, that's false, true, and it clearly shows different results. But why does removing parentheses do that? What happened there? Again, don't answer in the chat. Don't call it out on the mic because then I can use it as an exam or a quiz question. It's just as soon as I saw it, I was like, "There's something. Why does this false and false? That shouldn't be right." But okay. All right. So coming back to this again. Okay. And let's do one more just for fun. Okay, S1, S2, S1, S2, S1, S3, and S2, S3. Okay. All right. So this is going to be what? Does S1 point to the same thing as S2?
No.
No. Does S1 point to the same thing as S3?
No.
No. Does S1 point? Does S2 point to the same thing as S3? No. Okay.
No.
All right. What about which one? Somebody said why? Why? Which one?
All of them.
Yeah. So this created a new object by default, right? Then this, we forced it to create a new object and not use an existing one. And then this one, we did the same thing. We forced it to create a new object and not an existing one. So again, if we look back at it here, wait. Right, the object references 176, 181, 182, none of them point to the same object in memory, even if they have the same value. Okay. All right, so now let me change up something here. Okay, what's it going to be?
All of them.
All of them. All of them what?
False.
All of them false?
Yeah.
Okay. None of them true?
Yeah, why would it be?
Let's see. 176. Up. 176. Up. 176. Ah, they're all true.
Oh.
And this has to do with what we just talked about, the interned strings. That when we create a string like this, at runtime, it'll say, okay, if I see that same string again, I'll reuse it. So here, because it sees it the same way, it reuses it. Okay. Now it has to be exactly the same. So for example, if I do this, okay. Now, what happens? Okay, 176 as we would expect. 181 for S2 because it's a different value. It's a different string, all because one character is different. But we use the interred string for this last one because it is the exact same. All right. Okay,
But
so
those
only
strings
S1
are not object, right?
They're
Those
not what?
strings are not object, right?
Yeah, no,
Object.
all of them are objects. They're string objects. See, OBJ, object.
Oh.
All right. Okay. So here's one final one. Okay, one final question. So let's make them all the same. This way. Okay. Any false? Any true? I compiled, so that was fine. Okay, Ibrahim says false, false, true. Let's see. Well, S1 becomes 176. Metahan says he thinks all true. Okay. Let's see. This will tell us, right? S2. What's S2? 181. And then yep. So false, false, true, like Ibrahim said. Okay. So what we learned from this is that when we create a new string using the new operator and the string constructor, then what the execution does is it creates a new object, completely new object, and does not hold on to it as what we call this interned string. So it doesn't use it for future reference. If we create a string object using this format, without the new operator, without the string constructor, then not only does it look for a previous string that it constructed this way. So like here when it sees it, oh, I already made that string before in that same way. I already have that in memory. I'm just going to use that one. Okay, so it uses it again if it exists already, and it holds on to it for future. So it says, okay, I created this like this. I might do that again, and because of that, I'm going to hold on to it for the future. Okay. All right. So strings are a very special object type. Very special object type in Java. Okay. We talked about replace and some of this other stuff last semester, so I won't necessarily go into all that again. All right, we did talk about some of this last semester about how we can replace characters with other characters. We can replace strings with other strings. All right. One thing is we can replace just the first instance, or we can replace all. Right. One thing that I want to point out again is that just like I did, I think I did last semester, strings, you cannot change the characters of a string. What replace does, it returns a new string. Right. It does not change the original string. It simply returns a new string with this character replaced with this other character. Okay. Now, one useful tool is splitting a string. So if we might have something like this where we have tokens between like these what's called delimiters, right? We can say take a string like this, split it on a particular character, and what will happen is it will create an array of strings where each value in the array is the characters between the delimiters. So this array would consist of Java as one value, HTML as the second value, Perl as the third value. Okay, so you can split along that delimiter value to create an array of tokens, basically an array of strings. And then in this case, they go through each value in the array and print them out separated by a space. Okay. Notice this does not replace. This isn't a replace method. This is creating an array, and we can do different things with that array. Okay. So like last semester when we created a menu, right? A menu of items for our store program. Right, one of the things that we could do is we could create a single string that was separated by delimiters that was all of the different value, the different products in our store, right? And we could split them out into an array using a delimiter like this, using the split method. Okay. I'll leave the pattern discussion for you guys for home. Also, some of you know have read up on string builder and string buffer. Those are useful. They're like the string class. They're similar. There's some similarities. It is more flexible. You can manipulate, change individual characters and individual sections of a string buffer. So it is not what we call immutable. It is not unchangeable, right? But I'm going to leave that for you guys to look at in your own time because I want to get to the inheritance discussion. All right. Unless there are any particular questions about strings, about that discussion before we move on to inheritance. Because your first assignment that I'm hoping to have up and posted this week is going to have to do with inheritance. So I want to make sure we get to that today.
Joseph Hocam.
Sure.
With this last situation you created where you new string the S1 and just named the other S2 and S3 normally without using the new line. Does that mean when we name a string, there exists a place for those strings to hold that name? What I'm trying to say, if you create a new string, you just create a second one, but a first one is already exists, and you name those without using the new line, if I can explain it.
Yeah, so like what if I think I understand what you may be getting at. So when this line was executed, it created an object in memory for this string here. And then it pointed S2 at that object in memory. At the same time, it also recognized that I might need this particular string again at some point. So I'm going to hold a reference to it so that if I see that string again as part of an assignment operation, I'm going to use that object instead of creating a new object. So then when it saw this, it said, oh, I've seen that before. I've made that string before. So what I'm going to do is I'm going to point my new variable at it instead of creating another string object. Does that make sense? Is that what you were asking about?
What I'm trying to understand is, didn't we already create that object with S1? Why doesn't S2 go to S1?
Okay, so the way that we created S1 didn't allow the execution to keep track of it. Because we used the new operator instead, something about the way that Java is done, you'd have to talk to the Java developers, the people that created this, to find out why. But for some reason, if we create an object like this, if we create a string object like this, we don't hold on to it for future use. So even though the exact same value happens here, it doesn't understand that we already had that once before.
I think I understand it now.
Okay. Now what we could do is and now S1 and S2 do point to the same thing, right? That's not always the way that we do that. Let's see. All right. Okay. All right. So the reason why, part of the reason why I wanted to hurry up and get to the inheritance discussion. All right. So this is fun. This is for me, who learned programming using C, this whole object-oriented programming, inheritance, is kind of a really cool thing. So, because we didn't have this stuff with C programming, this is kind of one of those really foundationally good things about object-oriented programming in Java. So, we'll talk about why. Why do we want to define certain classes in terms of other classes? Well, sometimes what we want to do is we want to define a base type that all of the other types of it have things in common. So, for example, we want to define aspects of people that are at our university. Right? And there are certain things that all people have in common, right? All people have a name. All people have a surname. All people have a birth date, all right? Things like that. But then there are some things that make them different. Like students at our university have different special traits that professors and teachers don't have. And teachers have certain things that we track that students don't have, right? So we would like to be able to, instead of having to store things like name and surname and birth date all in the student object, what we would like to have is something like maybe a person object, a person class, and then students are seen as a type of person. Yes, they are. Yeah, don't let anyone tell you otherwise. Students are a type of person, and that way they get some of those traits like name, surname, from the person class, and we don't have to store them directly in the student class. Okay, it avoids what's called redundancy, right? There's this idea that since all students and professors all have names, we don't want to have a variable for name in a student class and a variable for name in a professor class. What would be nice is if we had a variable for name, one variable for name in the person class, and then students and professors both got that because they are types of people. Okay. So the way that we'll draw that in UML is with this symbol right here. Okay. I'll circle that here. So this symbol right here tells us that a circle is a type of geometric object, right? A rectangle is a type of geometric object. And so that way, these things like color, whether or not it's filled, what date it was created, are all things that exist for all geometric objects, and circles get that from the geometric object class. And rectangles get that from the geometric object class. Okay. Now notice that circle has a radius, but rectangle doesn't, right? Because that's something that's distinct. That's only in a circle, right? Rectangle has a width and a height because that's something distinct. That's something specific to a rectangle. Okay. Now, methods, attributes are all inherited. So if a circle has a color because it is a type of geometric object. A circle has the get color or set color method because it is a geometric object. Where's my pointer? Right. A circle has all of these methods because it is a geometric object. Right. So classes inherit their methods and their attributes from their parent, but then they also have attributes and methods for themselves too. Okay, that makes sense. But what about the constructor? The constructor is a special method, right? The constructor is not inherited, right? It is invoked explicitly or implicitly. Okay, and we'll talk about what that means in just a second. We can either explicitly invoke the constructor of a parent by using the super keyword. All right. Why is this? Hold on. Trying to figure out how to get that off of here because it's blocking my text over here. All right. How do it? Nope, that's not work. Okay. I don't know. It's not working. Okay. We can use the super keyword to explicitly call the constructor, or they are implicit if we don't. If we don't include the super keyword. Let me show you an example. Let me show you that through an example here. Okay. So here, if we create a public A, for example, let's say this is a class called A. Bad class name. Don't call it class A. All right. It is the same as if we had typed super alone with no arguments. So if we don't tell the compiler which constructor to call, the compiler will automatically try to call the no argument constructor. All right. If we put some statements inside of a constructor for our A class, it will automatically try to first call the superclass, the parent class constructor with no arguments, and then do whatever other statements we said. Okay. This is really important because this comes back to something that I did last week. I think it was last week. And I said it was a reclam or something for the future about the why we were getting a compiler error in a certain situation. All right, we'll talk about that now. All right. I don't think I have it up ready, so we'll do it after the break here. The break will be in like 5 minutes, so we'll do it after the break. Okay. So if we don't explicitly say what constructor to call, it will call the no argument constructor. Okay. All right. So the super keyword can refer to the superclass, right? So the parent class of the current class that we're in, the current thing we're trying to call. Okay. We can use it to call a superclass constructor, to call a superclass method, to get access to a superclass attribute. Okay. You call the keyword super to call the superclass constructor. Right. If you just use the superclass name, so like geometric object, but not super, geometric object, and that's it in a subclass, that would cause a syntax error. All right, so you have to, I want to specifically call a particular constructor of the superclass. Because remember, one of the things that we talked about last week was we talked about having multiple constructors, right? That we could overload the constructor. Right? So we can have more than one constructor in a class. So for example, here, notice here, the employee class has two constructors, one with no arguments and one with a string. Okay. And as the hints can tell, as we run this main method of the faculty class, right? When we run this main method, the order of how these things would display is shown, right? 1, 2, 3, 4, and we'll see why. Let's talk about why. Let's do the trace execution. Talk about the why this is executed in a certain order, and then we'll take a break. Okay. All right. So we should know the first thing that happens, right? We start from the main method. Right. Pretty easy. All right. Now, the first line in the main method is we're creating a new faculty object, which means we're calling the constructor of the faculty class with no arguments, which means we're calling this method here, right? Okay. All right. Now, a faculty extends employee. So before it does this line, before it does this print line, the first thing that the no argument constructor of the faculty class does is it calls the no argument constructor of its parent class, employee. Okay. Well, what's the no argument constructor of employee do? That's right here. All right. Okay. Now, this calls this is the constructor of the current class I'm in. So it's going to call the constructor of the employee class with a string argument. So it's going to call this here. Here. With this parameter. So S, so this string is passed to the string parameter S. But before this line is executed, the first thing this is going to do is going to look for, oh, I have a parent person. It's going to look for a no argument constructor in the parent class person, and it's going to call it. Okay, it's going to invoke the person constructor. Now, the first thing this is going to do is it's going to look for its parent. Does it have a no argument constructor and call it? Now, there is no parent, or at least it looks like there's no parent. We'll see later that there actually is a parent class here, and we'll talk about what it is. But for now, just say, finally, we've reached a place where we aren't calling parent constructors anymore. Oh, finally. Okay, so now we execute this. Execute print line 1, right? Person's no argument constructor is invoked. Now, once that's done, it goes back to here because this was that hidden line, that hidden super with no argument, right? And now it executes this print line S. Well, what was S? S was this 2, invoke employees overloaded constructor. So then we would execute that print line with the number 2 string. Now, once that happens, we return back to here. We come here, we execute this print line, 3, employees no argument constructor, and then we come back to here because now we've done executed its super, right? And then we do 4, and we execute the print line there. Okay, I said we were going to have a break after this, but let me do one more slide and we'll talk about why, okay? Because I do want to put this out there, okay? This simple piece of code would give us an error, okay? Let me do this. This will be a reclam because it's a very similar reclam to the last one. So let's put that out there as a why question that we will discuss at the beginning of the next section here. Okay, so let's take our break. We'll come back at 4:30 and we will continue our discussion and we'll talk about why there are errors in this simple piece of code right here. All right. I guess are there any questions or comments before we take a break? Nope. Okay. All right. Let's do this. We'll turn off the recording and we will take